Turns out, AI, catching what doctors miss in the ER. Your doctor almost missed something that could have killed you, not because they're bad at their job, but because the emergency room is a hurricane of noise, and in that chaos, one critical clue slipped through. What if an AI could catch what human exhaustion cannot? Context. Emergency departments see tens of thousands of patients every single day across America. Chest pain, broken bones, infections, strokes. The pace is relentless. Decisions happen in minutes. And sometimes, after the patient leaves, after the paperwork settles, someone realizes the doctors got it wrong. Not because they missed obvious signs, but because the evidence was buried in a file, mentioned casually, hidden in plain sight. These moments are called missed opportunities for diagnosis, and they're more common than anyone wants to admit. Until now, hospitals have tried catching these errors using what's called eTriggers. Basically, if a patient came in with chest pain and left without a heart attack workup, a computer flag goes up. Simple pattern matching. The problem? It doesn't work very well. The yield is low. Most flags are noise. Most missed cases never get caught at all. What if instead of playing simple pattern matching games, we asked an artificial intelligence to actually read the patient's entire story? Researchers. This study comes from a serious coalition of emergency medicine researchers. The lead team includes Christina Marks and colleagues at Georgetown and Harvard, the big names in this space. We're talking Beth Israel Deaconess, Boston Medical Center, and institutions across the Northeast. The work was published in June of 2026 in JAMA Network Open, one of the top medical journals. These aren't fringe voices. These are the people who train the next generation of emergency doctors. What they wanted to know was simple but radical. Could a commercial large language model, basically the same AI technology that powers ChatGPT, actually help identify cases that fell through the cracks? The study. Here's how they did it. They took eTrigger cohorts, those patient cases that had already been flagged by traditional pattern matching systems, and they fed them into a large language model. The AI read the actual clinical notes, not summaries, not structured data, the messy narrative notes that real doctors write in real time during a shift. Everything. What the patient said, what the physical exam showed, what labs came back, what the doctor suspected but didn't pursue. Think of it like this. Traditional triggers are a metal detector at airport security. They beep when something might be metal, but they catch lots of false alarms and miss things too. The LLM is like giving that metal detector eyes and a brain. It reads the full context of what's happening in each case and makes a judgment call about whether something was genuinely missed. The researchers ran this across multiple emergency departments. Real patient records, real stakes. They asked, does this AI actually catch cases that traditional triggers missed? And once it flags something, is it actually a real missed opportunity, or is it just another false alarm? The findings. Here's what happened. The large language model identified missed opportunities for diagnosis at a substantially higher rate than the traditional eTrigger approach alone. We're talking about cases where the AI recognized patterns in the clinical narrative that suggested a diagnosis should have been considered, but wasn't. The specifics matter. In cohorts where traditional triggers were already working reasonably well, the LLM added meaningful signal. It wasn't just finding the same cases twice. It was finding different cases. Cases that didn't fit neat pattern-matching rules, but made perfect sense when you read the whole story. More importantly, when external reviewers looked at what the LLM flagged, a significant portion of those cases actually turned out to be real missed opportunities. Not all of them. The model isn't perfect, but the accuracy was higher than prior approaches. The signal-to-noise ratio improved. Fewer wasted reviews of false alarms. More genuine cases of diagnostic failure surfaced for learning. This matters in concrete terms. If you're a hospital quality officer reviewing 10 cases a day looking for problems, and 8 of them are noise, you're going to miss the 2 real problems. Your brain gets fatigued. Your attention wanes. But if the AI can cut that down to 5 cases, with 3 real problems, your human judgment suddenly becomes vastly more effective. The tool doesn't replace the human reviewer. It just points them at the right cases. What this means, in practical terms, if this scales, it changes how hospitals catch and learn from mistakes. Instead of waiting for a patient to come back and complain, or for a malpractice attorney to get involved, these diagnostic failures could be caught internally, reviewed, and learned from. That's not just better for the hospital's legal exposure, it's actually better for patient safety. You catch patterns, you retrain staff, you prevent the next person from experiencing the same miss. But here's what we need to be honest about. This study shows promise. It doesn't prove the system will work everywhere, in every hospital, with every patient population. The cohort was regional. It was focused on eTrigger cases, which means it was looking at cases that already seemed suspicious. The AI might be much less useful in a truly unfiltered dataset. We also don't know the downstream effects. Does reviewing more cases actually lead to better care, or just more defensive documentation? That's an open question. There's also the thornier issue. Who trains the AI? What data went into these models? Commercial LLMs are trained on massive internet datasets. Medical records shouldn't be in there, but we're still learning what these models absorbed and how they can make mistakes that humans wouldn't make, or repeat biases from their training data. The bigger picture. This study sits at the intersection of a huge shift in medicine. For decades, quality improvement in hospitals meant human experts reviewing charts and making judgment calls. It was slow, expensive, and inconsistent. You could miss half the problems, but it felt trustworthy. Human doctors judging doctors. Now we're asking, can a machine do this better? Not perfectly, but better than the current status quo. And that challenges something fundamental about how we think medical expertise works. We've assumed that catching diagnostic errors requires the kind of reasoning only experienced physicians possess. This research suggests that pattern recognition at scale, something machines are actually better at than humans, might be part of the answer. But it raises a question nobody has adequately answered yet. What happens to the feedback loop? If hospitals use AI to catch errors, learn from them, and improve, do we actually get better at diagnosis over time? Or do we just get better at catching errors in our charts? Sign off. The most striking thing about this research is that it suggests your next missed diagnosis might not be caught by a more careful doctor. It might be caught by a machine reading between the lines of what was already written, and that machine might be better at it than anyone expected. So here's the question that should haunt you. If AI is catching what your doctor missed, what else is it noticing that we haven't asked it to look for yet? Turns out, scientists have been busy, and they're not done yet.